Welcome to Buzzword Breakdown, the series where we unpack the future of telecom, one buzzword at a time. Today's topic, in-network computing or INC. And here with us is Mrs. Affa from Docomo Eurolabs, a researcher working on next-gen network architectures and 6G.
Thank you, Clea. So yeah, in-network is one of the radical shifts in how we think about the network. And indeed, it's gaining a momentum right now, yeah.
So let's start with the basics. What exactly is in-network computing?
In network computing, I would say it means to offload and push computational tasks to be processed in the network. And devices such as routers and switches can start to filter and aggregate packets and also make AI inference instead of only forwarding packets. And most importantly, nowadays is for the telco industry is the usage of hardware resources that were once only used by network functions, be it in the access network or the core network. Use those hardware resources also to perform tasks such as AI, ML inferences or XR rendering. Yes.
Okay, so the network isn't just a highway, it's also a processing center.
Yes, exactly, you got it right. So, and that helps to reduce the latency and also saves in the bandwidth and open up entirely new possibilities and opportunities for real-time services.
Okay, and why is this idea catching on now?
I would say three reasons. The first one is that we need to process data near the end user. The second one would be, I would say, that the AI workloads become much more lighter and distributed mainly. And the third one is that the networks became programmable through SDN, P4 and open APIs, and also we can leverage the virtualization to run tasks side by side on the same hardware.
Yeah. Okay, so we already have the tools to make the network smarter.
Yes, and as 6G evolves, we expect that the network will play much more active role and adapting in real time to user behavior, application needs, and also resource constraints.
Okay, and what does this look like in practice?
I can give you scenarios, for example, filtering the irrelevant data from whatever your sensors are sending to the network before even it reaches the cloud, and running video analytics on top of the shared hardware resources at, for example, the access network, shared and side by side to the network functions. And you can imagine a network slice that can adjust its quality of service policy in real time and using local inference. So all of that is happening inside the network, not like in a server, remote server or central cloud.
Okay, so that sounds very fast and efficient.
Yeah, exactly, and it reduces latency, and as I said, it saves in the core bandwidth and also makes services more resilient.
Okay, so this sounds very exciting, but what are the challenges?
Several ones. First, we need standard ways to deploy those processing tasks in the network, and once we do that, then the security and isolation becomes critical because it's shared infrastructures, exactly as it's for the cloud, for example. It's the same challenge. And the third would be the business model. So who pays what and in the network computing, and also how we manage the service level agreements.
Okay, so it's not just a technical shift, it's an architectural and economic one too.
Exactly. So it touches everything, as you
Okay.
said. So hardware, software, operations, and even regulations.
Okay, so to sum it up, in-network computing is about turning the network into a computer fabric. It's programmable, intelligent, and close to the action.
Exactly. So it's the nervous system of the next generation network, and it's still evolving both technically and in terms of regulation also. Yeah.
Perfect, thank you.
Thank you.
Bye-bye.